To understand the impact of environmental stresses on human health and work to improve it, we really have to understand the air we breathe. Until now, air pollution models have operated at a large scale and a slow pace that's often inaccessible to users who work at the interface where change can really happen. My team and I are using Isambard-AI to create a high-resolution pollution modelling framework, importantly that's going to be open to all. I'm David Topping, Professor of Digital Environment and Director of Digital Worlds at the University of Manchester, Department of Earth and Environmental Science. Our project is a collaboration with AI tech giant NVIDIA. We've taken their existing Earth-2 generative AI system, originally created for climate and extreme weather modelling across Europe, and retrained it to focus instead on pollution in the UK. We've done this by inputting 1 year's worth of UK pollution data, simulated at hourly intervals. This requires extraordinarily powerful computing, which we got from the Isambard-AI supercomputer. As well as reframing what these generative models can predict, moving from weather to pollution, in this project we've shown that these frameworks can be used to learn from the huge 50 km² area across Europe to generate the much smaller 2 to 3 km² area across the UK. That's an operation that now happens in seconds to minutes rather than taking days to complete. Despite its huge impact on our work, the required time on Isambard computer was just 2 days on a single 8 GPU node. This is a far cry from some of its other users who would spend hundreds of thousands of GPU hours on data-heavy projects such as video analysis. While Isambard-AI is world-leading in sustainability for supercomputers, it still uses significant power, so it's really apt that an environmentally focused project dedicated to air quality is itself so light on compute time. The result of this first phase of our project has given us a detailed UK-wide pollution model. This allows us to look back at what's happened over the past year across the country, but also model what's likely to happen in the future. It's particularly useful to predict the outcomes of possible future pollution-related government policy changes, such as if you reduce ammonia discharge from the atmosphere, what's going to happen. In the next phase of our project, our aim is to offer this workflow to the entire world. We hope that every global country and every major city with a small burst of supercomputer AI time will be able to produce their own detailed pollution models from their own local data. With the modelling itself, the next stage we're working toward is an even higher resolution model, and also the ability to build an entire framework on openly available data. This will reveal exactly how local conditions, like specific road junctions or a nearby forest, affects the air that we breathe over time. Our ultimate hope is that researchers everywhere can use this framework to create street-scale pollution models for their own cities, protecting the health of their own communities.